Hello everyone, I welcome you all in the series of lectures on biomolecule. Today is our 12th lecture. Before going to the details of today's lecture, I will like to give a recap of my last lecture. In the last lecture, we discussed about the vitamins and we learned that vitamins are necessary for in a small amount for our good health, and they has to be incorporated by dietary intake. Our body can synthesize only vitamin K and vitamin D, and that also not sure that it can be synthesized in appropriate amount. Based on the nutritional value, these vitamins has been classified in water soluble vitamins, water insoluble vitamins, and there we discussed about all the vitamins, vitamin B1, B2, B6, all these water soluble and water insoluble one, their dietary intake and their deficiency can can lead to the what kind of diseases that we have already discussed. Then we switch to another biomolecules, nucleic acid, and we learned that nucleic acid, particularly DNA, RNA are made up of D-ribose. RNA is made up of D-ribose units which are linked together by phosphodiester linkages, and DNA is made up of 2-deoxy D-ribose 5-membered sugar unit, which is linked with another sugar unit by phosphodiester linkages. Also these sugars are linked with the different bases. DNA has two purine bases, adenine and guanine, and it has two purine bases, cytosine and thymine, whereas RNA instead of these all three, adenine, guanine and cytosine, instead of thymine it has uracil. So, I will continue with the nucleic acid, and there I was talking about the nucleosides, that a compound containing a base bonded to D-ribose or 2-deoxyribose is called a nucleoside, and particularly we are talking about the nucleosides in RNA. So, this is adenosine, and with the guanine it leads to the guanosine, with the cytosine it leads to the cytidine. Here you can see that this in all these nucleosides 5-membered sugar is common, and it is kind of linked beta linkages, beta glycoside linkage with the bases, purine and pyrimidine bases. So, the last one uridine, I was saying that the uridine structure similarly, uridine also has 5-membered sugar D-ribose, and it is linked with the base. Okay, this is uridine. Now, I will talk about the nucleosides in DNA. Nucleosides in DNA. So, as I mentioned that DNA has 2-deoxy D-ribose. So, I will draw first 2-deoxy D-ribose. So, 2-deoxy D-ribose, and again here base, So, base here. I will like to correct again the drawing, the earlier nucleosides in RNA also. Here I have forgotten the bonds. So, I am correcting it, adenosine, guanosine and cytidine. Now, nucleosides in DNA. What is important here, that only sugar will be 2' deoxy. As you can see here, 1', 2', 3', 4' and 5', sorry 5', 5', 5'. So, this is the numbering pattern, and this becomes 2-deoxy adenosine, 2' deoxy adenosine. Adenosine. Now, I will draw guanosine one. Guanosine one. So, 2' deoxy guanosine, 2' deoxy guanosine, guanosine. Similarly, cytosine 1. So, as we know that at 2' position there will not be hydroxyl group. So, this becomes 2' deoxycytidine, 2' deoxycytidine, 2' deoxycytidine, and finally, thymidine, thymine based. So, thymidine, thymidine, thymidine. So, these are the nucleosides in DNA. Now, I will talk about nucleotides. What is nucleotides? A nucleotide is a nucleoside with an hydroxyl group. A nucleoside is a nucleotide is a nucleoside with an hydroxyl group of the sugar bonded with an hydroxyl group of the sugar bonded in an ester linkages. In an ester linkages, linkage to phosphoric acid. To phosphoric acid. Nucleotides. A nucleotide is a nucleoside with an hydroxyl group of the sugar bonded in an ester linkage to phosphoric acid. A nucleotide is a nucleoside with an hydroxyl group of the sugar bonded in an ester linkage to phosphoric acid. The nucleotides of RNA are more precisely called ribonucleotides. More precisely called ribonucleotides. Ribonucleotides, and those of DNA are called deoxyribonucleotides. Nucleotides of DNA, deoxyribonucleotides. 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 The base names in nucleotides are the same as those of nucleosides. Okay. So, how can we write it in equation form? Nucleoside is equal to base plus sugar, and nucleotide base plus sugar plus phosphate plus phosphate. Okay. So, if we take adenosine and couple it with the phosphate linkage, the hydroxyl group of sugar, if the 5 position hydroxyl group of sugar 5 prime position gets linked with the phosphoric acid, it forms phosphate, then it becomes nucleotide. So, I will write nucleotides, adenosine nucleotides, adenosine based. So, this is the base, I am writing first, and next 2, and as I mentioned that at 5 prime position it will form ester linkage with phosphoric acid. So, I am here giving the adenosine 5 prime monophosphate, adenosine 5 prime monophosphate, 5 prime monophosphate, AMP, adenosine 5 prime monophosphate. So, here monophosphate is there. Now, if ester is with the diphosphate, So, again I will draw the structure. So, since we are drawing adenosine, so adenine the base will be same, and here diphosphate linkage will be diphosphate. So, this is adenosine 5 prime diphosphate. 5 prime diphosphate. And this is known as ADP in running, adenosine 5 prime diphosphate. And finally, triphosphate adenosine adenosine triphosphate ATP, that is energy coin which gets synthesized in mitochondria of the cell, and this is power coin commonly known as. So, this is triphosphate adenosine triphosphate. Five prime triphosphate. Triphosphate ATP. So, we learn about the nucleosides and nucleotides. Basically, nucleosides are compounds formed by the condensation of base and sugar, whereas nucleotides are formed of base, sugar and phosphate. Now, nucleic acids are composed of nucleotide subunits. Nucleic acids are composed of nucleotide subunits. Nucleotides. So, nucleic acids are composed of long strand of nucleotide subunits. Nucleic acids are composed of long strands of nucleotide subunits. Nucleotide subunits. subunits. A dinucleotide contain 2 nucleotide subunit. A dinucleotide contains 2 nucleotide subunits. An oligonucleotide contains contains 3 to 10 nucleotide subunits. Nucleotide subunits. A polynucleotide contains a polynucleotide contains many nucleotide subunits. Many nucleotide subunits. So, DNA and RNA are polynucleotide. Here I will like to mention DNA and RNA are polynucleotides. Again, I will rephrase whatever just now I discussed. The nucleic acids are composed of nucleotide subunits. Nucleic acids, basically are having long strand of nucleotides, and if a dinucleotide is there, then it will contain only 2 nucleotide subunits. An oligonucleotide contains 3 to 10 nucleotide subunits. A polynucleotide contains a number of nucleotide units. So, DNA and RNA are polynucleotides. So, let us talk about the biosynthesis of nucleic acid. Biosynthesis of nucleic acids. Biosynthesis of nucleic acids. Nucleic acids are biosynthesized from nucleoside triphosphate. Synthesized from nucleosides triphosphates. Nucleoside triphosphates. Nucleoside triphosphates using enzymes called DNA polymerases for the synthesis of DNA or RNA polymerases for the synthesis of RNA. So, I will repeat again, nucleic acids are biosynthesized from nucleoside triphosphate using enzymes called DNA polymerases for the synthesis of DNA or RNA polymerases for the synthesis of RNA. for the synthesis of RNA. Okay, so let us talk about the biosynthesis. Now, as I mentioned that basically here I am going to talk about the DNA biosynthesis. So, I will take base here, and then since DNA I am talking, so it will be 2' deoxy, again another sugar unit, base. Now, triphosphate so, this is triphosphate, a phosphoester bond. This is a phosphoester bond. This is a phosphoester bond, and this is 5 prime. Basically, this is the 5 prime position. Now, it can react with another monophosphate, adenos 2 deoxy phosphate. So, here again base, and at the 5 prime position it has all right. So, again here hydroxyl group at the 3 prime, this will attack on the phosphoester, and then again cleavage will take place. This is again here 5 prime and 3 prime is there. This process again can lead to the another sugar unit, base here, and then at the 5 prime position phosphoester group. Now, this will again attack and three prime position. So, we can see that 3 prime hydroxyl group is forming the phosphodiester linkages while attacking on the phosphoester group at the 5 prime. So, we are moving from 5 prime to 3 prime, 3 prime nucleotide add 2 at the 3 prime end. Here nucleotide add to the 3 prime end. So, now we understand that how the biosynthesis of nucleic acid happens. How does it keep on, the nucleotide keep on adding the phosphodiester linkages at the 3' position. So, let us talk about the primary structure of a nucleic acid. Primary structure of a nucleic acid. Nucleic acid. So, the primary structure of nucleic acid is the sequence of bases in the strand. Sequence of bases in the strand. Remember that while talking about the primary structure of protein also, we discussed that what is the sequence of amino acid in the primary and the disulfide bases. Here also in the primary structure of nucleic acid, basically the sequence of bases in the strand we learn about. So, remember that nucleotide at the 5' end nucleotide at 5' end of the strand has an unlinked 5' triphosphate group, and unlinked 5' triphosphate group. And the nucleotide at the 3' end nucleotide at 3' end has an unlinked 3' hydroxyl group, as you can see in the biosynthesis, 3' hydroxyl group. To explain it again, the biosynthesis of nucleic acid, you can see that this nucleotide is reacting at the 3' position. 3' position, it has unlinked hydroxyl group, whereas at the 5' position it has triphosphate, basically it has triphosphate. So, just for the representation I can write here different bases So, this becomes 5' end and this is 3' end. 3' end will have only hydroxyl group. Now, let us talk about the secondary structure of DNA. the secondary structure of DNA. Secondary structure of DNA. Watson and Crick concluded with the aid of Rosalind Franklin's X-ray data. Basically, the secondary structure of DNA was proposed by Watson and Crick based on the information provided by Rosalind Franklin. He provided the, Rosalind Franklin, she provided the X-ray structure, and based on that, Watson and Crick proposed the secondary structure of the DNA. So, DNA, what is that? DNA consists of two strands. DNA consists of two strands of nucleotides with the sugar phosphate backbone on the outside, with the sugar phosphate backbone on the outside, and the bases on the inside. And the bases on the inside. The strands are anti-parallel. Another information is the strands are anti-parallel. They run in opposite direction, means they run in opposite direction. The strands are held together by hydrogen bonds. Between the bases on one strand and the bases on the other strand. And the bases on the other strand. And I would like to mention here that DNA strands are complementary. The DNA strands are complementary. The DNA strands are complementary. Chagov's data showing that adenine binds with thymine and guanine binds with cytosine. Chargaff data showing that adenine binds with thymine and guanine binds with the cytosine. So, Chagav's data shows, adenine binds with thymine and guanine binds with the cytosine. Thus, if you know the sequence of bases in one strand, you can figure out the sequence of bases in the other strand. So, if you know the sequence of bases in one strand, you can figure out the sequence of bases in the other strand. Figure out the sequence of bases in the other strand. So, to make it more clear, I will like to draw the structure of basically DNA. So, this is the here the phosphate linkages, again phosphate linkages, OH. Again this is, so this is 5 prime and this is 3 prime. Now, if it has thymine, then it will bind with base adenine. So, adenine I will draw here, and again here 5 membered here 5 membered. So, here adenine and here it has guanine. So, it will bind with the cytosine, and again here if I am taking thymine, then again the complementary will be adenine. Again if I have thymine, so it will have adenine, phosphate linkages, so on it will go. Let me put the hydrogen bonds here in these two complementary strands. So, what is here? Here again it has 3 prime position and this side it has 5 prime position. So, this strand is coming from 3 prime to 5 prime side, whereas this strand is coming from 5 prime to 3 prime side. Now, let us make the hydrogen bonds between the bases. So, thymine and adenine has 2 hydrogen bond, whereas guanine and cytosine has 3 hydrogen bond, and the distance between these two bases are 3.4 angstrom. Similarly, thymine and again, and if it has G guanosine and cytosine. So, this will have 1, 2, 3. So, bases on inside, bases on inside, bases on inside, and sugar phosphate backbone on outside. Backbone on outside. So, we saw that how 5 prime and 3 prime this end is bonded with 3 prime 5 prime strand by hydrogen bond. Hydrogen bonding dictates base pairing. Hydrogen bonding dictates base pairing. Base pairing the base pairing is dictated by hydrogen bonding. So, let us see thymine and adenine. So, let me draw the structure of thymine with the adenine. So, this is thymine and adenine. Two hydrogen bonds. It has 2 hydrogen bonds, and here it is connected with the N9 position with the sugar. Here also it is connected with the sugar. So, thymine and adenine. Thymine a pyrimidine base and adenine is a purine base. Now, let us talk about the other pair thymine adenine and cytosine and guanine. So, let me draw the structure of cytosine first. So, this is again in cytosine and guanine. This is the hydrogen bond. Again you can see the 3 hydrogen bonds are there in these 2 pair, cytosine and guanine. It has 3 hydrogen bonds. Three hydrogen bonds. So, I think now it is clear that how DNA is made up of. It is made up of 2 strands, and these 2 strands are complementary to each other, and they are bound with each other because of the hydrogen bonding between the base pairs. Now, let us talk about the double helix. The double helix. So, the 2 antiparallel DNA strands are not linear, but are twisted into a helix around. The 2 antiparallel DNA strands are not linear, the way I wrote in the primary structure, but they are helical and they are twisted around a common axis. So, I can draw the structure around a common axis. So, if I can take like this, like this, like this. So, this is the common axis around that. So, this is way actually the base pairs are planar and parallel to each other on the inside of the helix. Base pairs are planar and parallel to each other. So, these are the base pairs. To make it more clear, the double helix resembles like a circular staircase. The double helix resembles a circular staircase. Resembles a circular staircase. The base pairs are the rungs and the sugar phosphate backbones are the handrails. The base pairs, these base pairs are rung and the sugar phosphate backbones are the handrails. Base pairs are the rungs and sugar phosphate backbones are the handrails. Sugar phosphate backbones are the handrails. Handrails. The OH group of the phosphodiester linkages has a pK about 2. The OH group of the phosphodiester linkages has a pK about 2. About 2. So, it is in the basic form at it is in the negative form basically. So, it is in its basic form. In its basic form means negatively charged at physiological pH. Negatively charged at physiological pH. Physiological. The negatively charged phosphates repel nucleophiles, thereby preventing cleavage of the phosphodiester bonds. Negatively charged phosphate repels nucleophiles, and that is why basically since it is negatively charged at the physiological pH, and that is why they repels nucleophiles, so that it cannot attack and it cannot cleave the phosphodiester linkage. Now, finally, I will talk about the DNA and heredity. Heredity. So, DNA contains hereditary information. There must be a method to decode that information. I told that DNA contains hereditary information, and there should be a method to decode that hereditary message. Basically, how does it happen? As we know that the sequence of bases in DNA provides a blueprint for the synthesis of RNA. For the synthesis of RNA. For the synthesis of RNA. The synthesis of RNA from DNA blueprint is called transcription. The synthesis of RNA from DNA blueprint is called transcription. Transcription. The synthesis of RNA from DNA blueprint is called transcription. Now, the sequence of bases in RNA. So, this is I am explaining the decoding process, that how DNA hereditary material decodes the hereditary information. The sequence of bases in RNA determines the sequence of amino acid in a protein. Determines the sequence of amino acids in protein. Amino acids in protein. And the protein synthesis from RNA blueprint is called translation. So, from mRNA we synthesize protein. The synthesis of protein from RNA blueprint is called translation. 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 RNA is used for protein biosynthesis. So, here I introduce that the RNA used for protein biosynthesis. The RNAs used for protein biosynthesis. RNA molecules are much more shorter than the DNA and they are single stranded. Although DNA molecules have billions of base pairs, DNA molecules have billions of base pairs, billions of base pairs. RNA molecules rarely have more than 10,000 nucleotides. RNA molecules rarely have more than 10,000 nucleotides. More than 10,000 nucleotides. There are several kinds of RNA. What are these RNA? Several kinds. Messenger RNA, it's like messenger RNA, commonly known as mRNA. Messenger RNA is mRNA, whose sequence of bases determine the sequence of amino acids. Here, whose sequence of bases determines the sequence of amino acids. Sequence of amino acids. Ribosomal RNA, which is commonly known as rRNA, a structural component of ribosome. A structural component of ribosomes. The particles on which biosynthesis of protein take place. The particle on which biosynthesis of protein takes place. Biosynthesis of protein takes place. And the final one is transfer RNA. Transfer RNA, which is commonly known as tRNA. tRNA is the carrier of amino acids. Amino acids used for protein synthesis. Amino acid used for protein synthesis. So, the RNAs used for the protein biosynthesis I discussed, and as I told that RNA molecules are much shorter than the DNA molecules and generally single stranded, and RNA has only up to 10,000 nucleotides, and there are several kinds of RNA. Messenger RNA, where the sequence of bases determine the sequence of amino acid in the protein. Ribosomal RNA, a structural component of ribosome, the particle on which the biosynthesis of protein takes place, and transfer RNA, the carrier of the amino acids used for protein synthesis. Basically, transfer RNA used as a carrier. So, this much about the nucleic acid. Now, I will like to again count all the topics whatever we have discussed in biomolecules. We have discussed about the sugars, we have discussed about the enzymes, we have discussed about the vitamins, we have discussed about the nucleic acids, all these biomolecules we have discussed. And I hope now you have better understanding about the biomolecules. Please practice your question papers relevant to the preparation, and that I think after consulting these lectures you will not have any doubt. Thank you very much for the attention.